Air conditioners. We can't live without them. But did you know that we spend a lot of money just to maintain them? In 2019, heating, ventilation and air conditioning, or HVAC, was responsible for a fifth of Singapore's total carbon emission. In fact, HVAC is one of the highest contributors to greenhouse gases, second only to the industrial sector. That's why we have to keep our HVAC systems running as efficiently as possible. One of the main causes of inefficiency in our aircon systems is the presence of biofilms. A biofilm is a sticky, slimy substance made of bacteria that covers surfaces in all natural and engineered environments. When biofilms form inside HVAC systems, they act as an insulator and increase friction inside the cooling pipes. Ultimately, biofilm growth in HVAC pipes and cooling towers results in loss of cooling efficiency and increases energy consumption. This then leads to increased carbon emission and maintenance frequency. This problem is called biofouling, and it is clearly a big problem that is costing us a lot of money. Around $50 billion were spent per year to clear biofilms from aircon cooling towers in the US alone. Currently, removing and preventing biofouling is done by chemical disinfection. However, the chemicals currently used for biofilm suppression in HVAC systems can be environmental hazards by themselves. On top of that, they are expensive to buy and dangerous to handle. Many companies and researchers have been trying to get rid of this slimy bane with various innovations. We are currently trying out a cheaper and more sustainable alternative for biofilm suppression. This is done by dosing nano-sized bubbles of ozone into the cooling system. However, it is not possible to investigate suppression properties and biofilm growth in real-life HVAC systems. So we have set up a scaled simulation in our laboratory that allows us to investigate a whole variety of different sensors and biofilm control methods. With SNBC funding, we at SCELSE are able to prototype, test and build a simulated system to model the HVAC, and this testbed is now available to the industry.
This is a simulation of the condenser cooling tower circulation loop, which is an essential component of centralized air conditioning facility. Our goal is to compare the fouling communities between a reactor equipped with a disinfection system and the one without. For this, we need samples of water from cooling towers, and we approach NTU facility management for this. Using water from an actual operating cooling tower allowed us to best simulate the potential growth of biofilms in the actual conditions in the condenser cooling tower water circulation loop. The biofilms behave differently on different materials, and it is important for us to test biofouling on materials that resembles real-life situations. And these devices and coupons allowed us to simulate the copper tubing used in the condensers. Our setup allowed us to take samples out from the system for downstream analysis, such as doing microscopy imaging in our laboratory. So, with this innovative simulator, we can test out various ways to rid aircon systems of biofilms. We hope that our simulated systems can help scientists and industry partners alike to solve the problem of biofouling and reduce inefficiencies in our HVAC systems.